Testing, testing. Testing, testing. Good afternoon, everyone. We'll be getting started in exactly 2 minutes. I want to see if anybody else is going to be viewing the live event today, viewing it live while we're doing it here. And let me know in the comment section that you guys can view my screen here and that you can hear me loud and clear. You can also see in the comment section our phone number and email address for technical support. Phone number is 727-489-0003. And email address is support@bobcad.com. But yeah, let me know in the comment section that you guys can hear me loud and clear, that you can see my screen clearly, and also if there's any questions, comments, concerns, any questions in the software program at all, I'm more than happy to field any questions you guys may have as we go through the live event today on advanced CNC lathe strategies. We'll be getting started in exactly 45 seconds. All right, let's get started today. Hey everyone, my name's Eric with Bobcat Cam. I am the demo technician with Bobcat. And so that means doing the demonstrations of the software program for any customers or potential customers that want to view the software program before they decide to purchase or before they decide to upgrade. I also am part of tech support, so you can call us or email us, and we can call you back, log into your computer, and answer any questions that you may have. And I'm also part of training. So we do live events like these every other Wednesday at 1 p.m. Eastern Time. We do, as part of training, we also offer online training where it's separate from technical support. You can purchase by the hour, purchase a one-on-one training session as a 1 hour or a 2 hour session with us. And we log into your computer and go through any part files you may need or go through any questions in the software program. And that is recorded so that you can review it afterward and ask any questions after that with tech support. All right, we'll get started today. Today is on lathe features, specifically advanced CNC lathe strategies. So I've got a part file here. You may be looking at it and thinking, well, you can't really turn down the part completely, especially with these areas here, that profile around it. But we'll be looking at strategies on how to turn the areas that we can on this part, create geometry to turn down the stock if we're looking at it from this sort of view here, turning down to this area so that we can use a milling tool or something to mill around the profile afterward. I got this from a customer and he's using a mill turn machine. So we went a little bit further involved than we're going today with using a lathe to turn down what we can and then using live tooling to use a milling tool on the lathe that he has to profile around it. But yeah, if I look at it from a top view, we're looking at it down inside of the cylinder like this. We need to get it on its side from this top view so that we can do our turning operations to start with. So let's take a look at how to do that first. Look at some of the CAD functions to help with our turning operations. So I imported this file as a SolidWorks part file, and now I need to reorientate it. I go to the top and I go to Utilities, and I go to Rotate. I select the solid model, and I'm rotating it around the y-axis. You can see if I'm looking at it from the side here, the y-axis here, and I'm rotating it around 90 degrees. And normally it has it here from our geometry center. Now I need to have it where the front face is at my work offset right here at the origin location. So I'm going to change the rotation center from the center of the geometry, pick my rotation center as x0, y0, z0, so it's rotating around the center of the origin location rather than from the geometry center. All right, and then I'm going to click OK. So easy as that. If I want to create my own drawing of the profile here to turn down the stock or create or measure anything or create the 3D model, I can go up to the top and go to my Home tab. And all the way to the right, there is a turning mode option. So if I'm familiar with sketching in X and Y coordinates, I can certainly do that. You can see where my cursor is with the X and Y coordinates here. But if I click on turning mode, you'll see those coordinates change to Z and X coordinates. So if you're more familiar with creating your profile like this here, when you're going to create 2D and you're sketching your lines to create the chamfer here, create the OD, and go around, you're sketching in Z and X coordinates like you would see on the lathe. All right, but we're not getting into creating the 2D drawing necessarily in here today. We're just going through some of the strategies in the lathe functionality. I imported a solid model like this, and what's really nice in the newer version of Bobcad V38 is when we go into the lathe operations, we can select our surfaces like this chamfer to turn down the stock down to this chamfer here. In the older versions of Bobcad, and also in relation to this area here, I want to just turn down, to this position right here. So I actually do want to get the wireframe for this, probably be the easiest way in Bobcad. I'm going to go over to my layers page over here, and I'm going to add a new layer. I'm going to make it active with this green check mark, and I'm going to name it wireframe. It's not necessary to name it a certain thing to have geometry like as a solid on a certain layer, name it wireframe. I just like it naming it that way just for my own preference there to remind me what's on there. So it's active with the green check mark here. When I create the wireframe, it's going to be blue with this color here, and it's going to be a solid line with this line style here. I'm going to go to the top of the page and go to this tab labeled Create 2D. And right next to my Extract Edges function, there's this function called Spun Profile. I'm just going to window select all of the surfaces here of the solid and click OK. It's going to create wireframe. You can see the ID right here, and you can see the OD and the tallest point of the OD right there of my solid model. So really easy to be able to create the wireframe of your turned part to select for your turning operations there. All right, cool. We're going to be focusing mostly on the OD functionality here today. And I'm just going to leave the wireframe turned on and just sort of do the turning operations this way. I'm going to go to the top and go to Cam and start a new job. And instead of a milling job type, I'm going to select turning and select my machine. So it defaults to this BC2X lathe that is our Bobcad 2-axis lathe, which is a Fanuc-based G-code when it outputs the code. And there's other machines in here by default. If you don't find your specific machine, you can go to our website, which you're on now for the live event. It's bobcadsupport.com. And up at the top, there's a tab for post processors. You can download a post processor there, and you just run the exe file, and it will import the machine and post processor for you for that specific machine you're using. Now, I'm just going to go back to the BC2X lathe, and we'll look at the Fanuc-based G code once we output it here. And down at the bottom, we'll click on Stock Wizard. Most customers will start with just clicking OK, because it makes the most sense, I think. But we're going to click on Stock Wizard so that we can define our stock first. Clicking OK just brings us to our cam tree to define that later. But anyways, I'm going to click on the Stock Wizard, and it asks for my workpiece. I have a 3D model here, so I'm just going to click on the 3D model and then go to my next page here with this next arrow button. And with the wireframe in the background now, I can see how large the stock has to be to at least start with to turn down my stock. Let's start with 4 inches for my stock diameter. Internal diameter is if I already had a hole drilled through, or maybe I've already turned down the ID, I can type in my ID here, and the length of the stock. So the OD is looking pretty good there for 4 inches. I can turn down this area here and turn down to here and the chamfer and all that. The length seems fine. Maybe I'll go 1 more inch. So I'll go 4 inches for the stock diameter, 4 inches for the length. That way we can do, let's see, I'm looking at doing a facing operation. I'm doing a turning on the OD. I'm doing a groove operation right here. Then we'll do another turning operation on the back side here. And then we'll do a cutoff operation and see some ways to advanced CNC lathe strategies to be able to cut down on air cutting, cut down on cycle time, setting our feed rate, or we could set constant surface speed, those kinds of options today. Then if we go to our next page, it doesn't have anything for our machine setup necessarily in terms of setting the position right here. It's always at the CAD origin location. So we want to set up our part file and our stock accordingly to that. But on this machine setup page, we have clearance planes for the face. So 1 inch out from the clearance plane there, from the work offset. Clearance plane from the OD, 1 inch above it. So when it retracts for tools and different operations and things, it will retract to this position and retract out from this position. And then ID is at least 50 thou here by default. Now, before I hit OK, one thing is I'm going to go to my previous page. And this last option here, stock origin. Right now it's at Z0, but I want to push it out a little bit further so I can do a facing operation first. If I don't have it pushed out, it's not going to see there's any stock here, and it's not going to face anything off. So I'm going to add an extra 50 thousandths right there for a facing operation. And then I'll click OK. So now you can see it brings us to our cam tree, and we have all of our turning operations once I right-click on Machine Setup 1. And you can see from here, we have, from the beginning, lathe end face, lathe turning on the OD or on the ID, groove, drilling, tapping, threading, cutoff, and stock handling for a bar feeder. Now we'll take a look at facing, then we'll take a look at turning, we'll take a look at a groove operation here into this groove, then another turning operation on the backside, and then a cutoff operation. So let's start here, go to lathe end face. It's going to ask me to select my geometry. I'm just going to select this vertical line as the face I want to face down to, and click OK. Next page. And you can see I'm in version 38, so everything is sitting inside of the software program here on the left-hand side. And you can see there's sort of this feature tree over here that I can switch over to. What I really like about this is when I select a tool, when I select a step over, and setting a depth of cut for my facing operation, and all of those settings. Up at the top, there's this button, Compute Toolpath. So when I hit Compute, it updates the toolpath for me that I can see. Instead of having to hit Compute, I can look at the toolpath, then I have to go back into the feature. I can just hit Compute to update the toolpath in real time and take a look at my changes from here. So again, from the beginning, I've selected my geometry as the vertical line here for my face. Next page, region 1 or region 2 would be if I'm starting from the top. I wish it would show me here. Doesn't show me a pop-up there. But region 1 would be if I'm starting from the top, working my way down, or if I'm starting from the bottom, working my way up, which region there. From stock would be all of the stock that's showing until I get to my vertical line here. Or you could also do a custom option where you could set your own distance if you wanted to just type in the number here. All right, but I've got the 50,000 from my stock so I can see it in simulation. Makes sense that way to do it. All right, and last option here is extension if I want to go a little bit further past the center of rotation there. All right, next page. We have different machining operations. We have a rough or a rough and finish. Next page, we can output in separate moves or in can cycles. And then our next page is our tool page. I can click on the tool crib. And we have our different categories of tools: rough, finish, groove, and boring bars. And I can select my tool from my tool library, bring it into my tool crib, and then save it for next time. So when I go to my next turning job, I can import my tool crib from here and select it and import all those tools for next time. All right, then I scroll down. I have my tool number, I have my spindle direction, coolant types, and then I have my spindle RPM and my feed rate, or I can output in constant surface speed so that when it's machining at this level, it's going to be the same speed that the tool is cutting based on the OD here and the OD here, for example. I'm just going to leave it as a just basic RPM. Just let it spin the chuck that way, and then the feed rate just go in the same feed rate the whole time. All right, next page. We have our collision system compensation, so it'll compensate for the tooltip. And then if I don't have collision detection turned on, you can see if like the tool holder might have a collision into the stock like this. I can change it to on with collision detection, so it'll avoid that area, and then I can come back with a finish tool to finish up this area that the tool couldn't fit into. Scroll down on this patterns and parameters page where I can set my depth of cut. I don't know, let's go 20 so that I can do a couple passes. Finish allowance, I'm leaving 10 thou on the sidewalls and on the floors for the finish pass to clean up. Not necessarily the floors for facing, but you get the idea. Next page, we have rapids, where the tool is going to rapid from, where it will rapid back after the operation. Next page is a lead in and lead out. So it's going to lead in parallel into the stock like that. And then lead out is on an angle as it angles out and then retracts out that way. Advanced feed rates. If I'm unable to set the rapid rate at the controller, I can change my rapid moves in the G code and change them to feed moves so that I can control that rate here. And I can also control the feed rate for my lead in and my lead out. And our last page here is MDI for manual direct input. I can manually type in any G code before or after the operation here. All right, and then our next page is going to be the tool page for my finish pass. And I'm just going to leave it as tool 1, and I'm just going to leave it as the feed rate that I have by default there. Next page, we have turning on collision detection. Not super necessary for my facing operation here, but I always turn it on, just force of habit, to turn on the collision detection there. 0 for my finish allowance because I'm machining to the face here with my finish pass. And then the same options as before as the roughing: my rapids, my leads, advanced feed rates, and MDI. And I'll hit compute. And now we've got our toolpath for the roughing and the finish here. If I want to see an operation before my full simulation here, I can go to the feature and I can right click on, let's say, the finish operation. Just right click on basic finish, go to backplot, and I can step through here and see it cut across the face there and then how far it's going to retract out. That's really useful if I'm like turning down the ID here and make sure the tool comes in correctly and retracts out the right way. But yeah, so there's our facing operation. We'll get into turning on the OD next. Let me know if you guys have any questions in the comments section. More than happy to answer them in the live event today. All right, so next I'll right click on machine setup 1 again, and I'll go to lathe turning, the next one down. And I'll select my geometry. Now again, since I've got my wireframe like this because of my part file, I can select the wireframe. Or if there are certain surfaces, I can change it from wireframe to solid and surface. So maybe if I just want to select these two surfaces and turn down this area right here, I can do it this way. But I'm going to change it to wireframe again. And I'm just going to start from my chamfer. I can click on each line individually. I can hold shift and click to chain select the rest of it like that. I'm going to deselect all of them here. And I can also window select everything here. But if you see where my window selection is, I'm selecting the back line there. I can just click on it again to deselect that. All right, perfect. I've selected all of the lines on the OD there, and I'm going to click OK. All right, I'm looking at the toolpath so far. It looks pretty crazy. It's coming down, going across from my first pass, coming up and out, and back here, coming down to the next pass. The next pass is going to rough all this out. Somehow it's going to try to rough all of this out and try to rough out the groove here. So we don't need all of this toolpath. We'll look at options on how to remove the toolpath for the groove, and also ways to avoid this area because the tool is not going to be able to fit into this area here. All right, next page. We're turning down the OD versus the ID. We also have options for front face or back face. It's going to do like a vertical cut like this if we have front face or back face. More like a facing operation. All right, it's going to be from stock. And then our next page, I'm going to select rough and finish again up at the top. It'll bring the rough and finish operations into my current operations list here. If there's any operations I want to add from my available operations, I can select one, like this pattern repeat option for spring passes. I can click on it and click on this arrow to bring it down to my current operations list. So when I go to my next page, you'll see a rough, a finish pass, and then pattern repeat. I don't want the pattern repeat option, so I'm going to go down to the bottom, click on pattern repeat that I added here. I can move it up or down in the list with these arrows here in the list of operations. And I can also delete any that I don't want with this red X. All right, cool. Got the roughing and the finish here. Next page, let's output in can cycles so that we can see our G71 and G72 can cycles here. And yeah, we'll hit compute and let's see what the toolpath looks so far. I don't see anything yet. Maybe, I think I have to select my tools first and then we can hit compute to update. There you go. So we're at our tool page for the roughing. Still doing all that crazy stuff. I'm just going to leave it as tool 1. But my next page, we have collision detection. So that should remove a lot of this area here on the backside. I'm going to go to on with collision detection. And then I'll update to see that. Okay, so it's removing all of that area there. Perfect. Now, if the groove was on this side, just to show you, I can go back to how do I remove just the groove, for example? Well, I'm going to go to my first page here on the turning feature where I'm selecting my OD and ID. The undercut options would be for a groove like that. You can see remove primary undercut would be if there was a groove on the front side over here. I can remove it like that, just checking the box. And then remove secondary undercut would be if there is an undercut on the front face like this of it in this area. Check that box and it'll remove the tool path in that area. But it's on this back side, so when I turn on collision detection, it's going to remove all that for me anyway. All right, so I'm back on the roughing tool. Go to my next page, turn on collision detection to remove all of that area there. Cool. What else do we have? You know what? I think we need to remove all of this toolpath anyway right here too, because we're going to do another operation, turning operation, where the tools, yeah, we could do the tool orientation flipped so that we can do the operations on this side. So if I have collision detection turned on, but I go back to that feature page and remove secondary undercut, it should remove everything across here. Nope, primary undercut. Remove primary undercut, and it's going to remove all of this area. You can see the red line here is showing the geometry that is cutting now. So I go to my tool page. Let's compute it. There we go. Perfect. So it's just turning all of this area here. Then we'll use another tool where it's going to be fixtured another way to be able to come in from the other side. All right. Turn on collision detection. Depth of cut we'll leave as 50. We'll leave 10 thou on the sidewalls and the floors here for the finish pass to clean up. Rapids, leads, advanced feed rates, and MDI. We've got our tool page for the finish pass. We'll leave as tool number 1. Turn on collision detection. Rapids, leads, advanced feed rates, and MDI. And we'll hit compute. All right, perfect. Let me know if you guys have any questions in the comment section. More than happy to answer them. And next we'll do the turning operation on the other side, then the groove, then we'll do the cutoff. Okay. I think we're looking good so far. Yeah, let's do that. Okay, so we'll right-click on Machine Setup 1. We'll go to Lathe Turning again. I'm going to select my wireframe as these right here. I'm going to include the groove and zoom in and make sure all that's red. Perfect. And click OK. Go to my next page. Turning on the OD again. What else do we have here? Region 1 or Region 2? Region 1 or Region 2? Yeah, it's either, so Region 1 would be this side, Region 2 would be on the flip side here. Yeah, that would be the option there. Remove primary undercut. You can see it removes that groove there. From stock or from geometry? Now I'm doing from geometry because if I did from stock, we look at our toolpath here. We look at our toolpath, it's going to try to, well, first of all, it's going to try to remove all of this stock that I don't need. And it's going to, well, yeah, how would that work? Okay, maybe I won't do the cutoff. We'll see. Anyway, you can see like all the geometry is going to try to do, and it's also trying to this is all air cutting right here, here, and here, because I've already turned down this area from my first turning operation. And you can also see the orientation of the tool is pointed this way already because of the region 2 option. Perfect. Just change back. Oh, there we go. Tool 2. Perfect. All right. I guess I would have to do that if I'm doing a cutoff operation with all this stock, or I could do a groove operation with all of this area, maybe with an OD groove tool. I'm going to change my mind on the cutoff for this one. We'll hit compute. We'll go to the stock wizard. So I'm going to right click on stock, go to stock wizard. Let's change the length to, I don't know, what is this? 2 inches? Let's go 2 1/4, I believe. So that is enough to be, no, I want to go all the way to it. So if I don't know the number, this is a good option. I can just right click on anywhere here in the CAD workspace, and I can go to Entity Summary. It'll show me how far out in Z I am, or I guess this would be the x-axis. It's showing me I'm at exactly 2 50,000ths, and that's a total of 2 50,000ths for the length. But we have to compensate for the extra 50 that I put on the front face there. So add 50. Perfect. All right, I'll click OK. Then you can see with my toolpath here, I can right click and compute the toolpath. It computes it based on the stock now. But again, still, it's doing the air cutting here. So instead of from stock, I'm going to select from geometry. Am I? Let's see. So that's doing from geometry with my geometry here. Okay, I have to select that as my geometry. Reselect. So I'm right-clicking on geometry under the feature. I go to reselect, and I select this line as well, and then compute. Perfect. All right, so it's just doing this area. It's not even going to try to get into this area because of the remove primary undercut on the first page as well. And I'm on region 2. Awesome. So if you guys have any turning operations on the other side of the part, that's the easiest way to be able to do it from there. If you're able to do it on your lathe, if you have to do a cutoff operation and then flip it over to do the other side, let's take a look at that next. That's probably a little more realistic than this option. All right, so we'll take a look at the groove operation that we'll do here, and then we will take a look at our simulation. All right, so I right-click on Machine Setup 1. I go to Lathe Groove, select my wireframe here as this here, and click OK. Next page, turning from the OD, region 2 again, from stock or from geometry. I'm not sure if geometry will, well, geometry should work, I believe, because, no, it shouldn't be from, because you can see if I did it from geometry again, even if I did it from geometry, when it comes down with the tool, it's feeding down from this location. I want to, theoretically, I guess I would want to feed from this location, I guess, right? And then turn just this area that's being removed. It might be a safety issue with this area here, but if I remove this from my geometry. I think I may just be able to do these two here and compute. Yep. So now the rapid move is going to rapid down to here, and then it's going to feed down into the material from right there. Perfect. The only thing I want to change is my tool, I think. I'm going to do a different groove tool. I'm going to do a rough and a finish pass. We have our tool page for the groove operation. I'm going to select an OD groove tool like this, and then change my mounting orientation up at the top of my tool crib here from 1 to, no, how do I change it here? It should be, once I click OK, then I've got left corner versus right corner. No, still not changing for me to flip it. Even if I've done region 2, select my mounting orientation. And then isn't there a tool orientation? Thought it would be left corner or right corner. Let's see if I compute it here. I think there's another option as well. I want to select the OD groove. I want to turn on collision detection. Then you've got also with the roughing, you also have the step over option and also a pecking option down into the groove there. And we'll hit compute. Let's take a look at the direction here. So here's the direction. It's going to start along this face and work back. If I want to go the opposite direction here, I can go to the feature. I can right click on default chain start point, reverse direction, right click, and then compute. And that should give us the right orientation for things, starting here and then going across like that. That should work for us. All right, so we'll take a look at our simulation. But first, I want to backplot this turning operation as well. Okay, yeah, so you can see the direction I need to reverse for this one as well. Again, that's under the feature. Right after geometry, I can right-click on default chain start point, reverse direction, and now you'll see the arrows going in this direction. I still have to right-click on the feature and compute that toolpath. So now that is going in the correct direction for us. All right, so we'll save our progress. I would be saving much more often if this was a real part file I was working on and need the G code for. Save often, and then up at the top, go to Start Simulation. Up at the top of simulation, you can see the NC mode will tell us how many lines of code, about 200 lines of code here. If I change it from NC mode to length mode, it's telling me 147 inches for the tool travel. And if I change it to time mode, it says it will take about 4.5 minutes to run these operations, 4.5 minutes for my cycle time. And that's based on the feed rate that I've set for each operation. So here's our facing operations. And then turning on the OD, turning what I can on the OD from this position here. Speed it up just a little bit. and then the groove operation. So that was the certain corner that we were running into. We could use the right corner of that tool and we wouldn't have the red there, but that's just showing that it's rubbing on the opposite side of the tool. If there were any collisions or anything like that, we would see in simulation. It will give us an error code and tell us if there's any collisions between the tool or the tool holder and the stock. But yeah, everything's looking good here. Let me know if you have any questions in the comment section on what we did so far. I'm going to do probably a little more realistic operations here where we're doing our facing. We're turning down the OD of this area here, probably all the way across out to here. Let's say we're going to do a cutoff, then flip it over, and we'll do the rest of this on the side after we've flipped it over on the machine. So we'll close out of simulation. I'm going to delete a couple of these here. Let's delete the groove operation. I'm just right-clicking on the feature for the turning operation on the backside and hit delete. So this is all we can take care of on this side, the facing and the turning on the OD. And for this example, let's flip it over. And well, first we'll do the cutoff operation here, then we'll flip it over and do the rest of this area here. So let's go back to our stock being a little bit larger. Let's go, I don't know, let's go 4 inches like we did before. Then let's do a cutoff operation. Then let's see how to flip it and do the second turning job. So I'll right click on machine setup 1. I'll go to lathe cutoff. Select my geometry. It's just like selecting the front face here for the facing operation. I'm just selecting this point. Well, normally I highlight the vertical line and then click on the bottom point as my cutoff operation. Next page, it asks whether from stock or a custom distance that I'm starting from, but I'm gonna, I really want to start here instead of here. That's a bit of air cutting. I should be able to go to custom and then pick this point I want to start at here. Perfect. All right, just doing a cutoff operation. Next page, I could output in separate moves or in canned cycles. I don't know what that would do with a cutoff operation necessarily. Then we've got our tool. I want to make sure the tool's long enough. I want to go, I was imagining the ID's already cut. So if we are just getting to this position, we'll just leave it alone. Go to our next page. We have our cutoff in Z and cutoff in X, which is this position right here. If I want to go down to the very bottom, I can just zero this number out. Like that. Next page, our rapids and MDI page, and I'll hit compute. Now, since I zeroed it out, we can backplot it and see it go all the way down to the bottom. I would change the geometry of the tool holder so that it has enough travel there. But I'm just going to go down to this position here for this example. I'm going to right-click on cutoff, go to edit, and let's see. I don't remember that number there. Can I pick my endpoint from the feature here? So in my cam tree, just right-click on endpoint, reselect, pick that point, and then compute. Perfect. If I want to go a little bit further past, I can always edit the feature, go to parameters, and let's say my cutoff, let's say I want to go an extra 100 thousandths. I'll just subtract 100 from it. And there we go. Perfect. So we'll save our progress in the part file. I'll blank out the tool path and everything here, so we're back to our wireframe. And this is the best way I know of to do the rest of the operations on this side after our cutoff operation. I'm going to go to my layers and I'm going to create the wireframe for the other side of it. I'm going to right click, go to add new layer. I'm just going to name it backside. I'm going to go to utilities. I'm going to go to mirror, the option right after rotate, select my wireframe, and then click OK. Well, sorry, before I click OK, I want to click copy so that I'm keeping my original here and just making a copy of it over on the other side. I'm mirroring it across this x-axis here. I can mirror it across the z-axis or mirror it on itself here. But anyway, yeah, I'm mirroring it over to this side, making a copy, and click OK. Now let me check if it's on the wireframe layer or if it moved to the backside layer with it active. I think just because it's a copy, it stays on the layer that its original was on. So I have to move it to the backside layer sort of manually. I'm going to go to my select mode here. I'm going to window select everything here that I need. And then this icon, the first icon is to create a new layer. The second icon is to create a group of layers in the layers page. And the next icon is to modify to current layer. So I'm moving everything that I have highlighted in red to the layer that is currently active. So now it's on the backside layer separate from everything else. All right. And the only thing I need to do is just move it to the wireframe position and then do my turning operations from my work offset, which is, again, always at the CAD origin location here. So probably the easiest way is just right click, go to entity summary, find out how far over I have to shift it. We're looking at 2 50 thousandths, as we mentioned before. Go to utilities, go to translate, select my wireframe. I'm going to shift it over in Z minus 2 inches and 50 thousandths of an inch. And we'll shift it over like that to the same position as my wireframe layer. And then just start from scratch. Go to CAM, start a new job, select turning, go to my stock wizard. I don't have my 3D model mirrored. I could mirror it over and place it where the backside layer geometry is, or I can just skip it. It's not totally necessary. Just helps in simulation. You can see how much material is removed based on your workpiece that you have there. Then we can set up our stock diameter and all of those options. Let's see. Do I want to create a cylindrical shape, or do I want to tell the software what I'm starting from, not a cylinder here. So it's going to be a little bit different, isn't it, than stock being 4 inches like that. Well, it's just going to be to this position here. I've already cut it off here. I could do another facing operation if I wanted to, but I'm really just focused on the OD and the groove here. So really all I want to do is right click, go to entity summary. My highest position here is 1 in 845. So I'll just go here to the stock diameter, 1 in 845 times 2. There's my position that I need for my material to be removed here. And then the length, I guess I could do the length as well, which is 2 inches and 50. Oops. Get it perfect there. And then click OK. And then just as we did before, I'm going to right click on Machine Setup 1, go to Lathe Turning. I'm going to select my geometry here. I clicked on this top OD line here. I don't need that one. We've already machined that down, so I'm just focusing on this area right here. I'll click OK. Go to my next page. I'm turning down the OD. I'm removing primary undercut, so you'll see the highlighted geometry change to this here without the groove. I'm machining from my stock, and I'm going to my next page. We're doing a rough and a finish pass. Next page. Let's leave it as separate moves for this one, because if I have it as separate moves, I can select my tool. And then on the next page under patterns and parameters, I'm going to turn on compensation with collision detection. And then down at the bottom, there's a newer option. I want to say this started in version 36. So a few versions back where we have this chip break option. So instead of the roughing operation going in the correct direction here, and going across, all the way across, for some machines or for some tools, there's a lot of material built up when it goes across, creates a bird's nest like that. You can go to patterns and parameters on a roughing operation and turn on chip break. You can set the length of the cut and the retract distance here. So the length of the cut as a 1/4 inch here will go across a 1/4 inch right here, and then it'll retract 50 thou that I set, and then come back down, and then go across a 1/4 of an inch each time. So that chip break option allows the tool to retract just a small amount as it's roughing, so that it doesn't have any built up material as it goes across there. This is a small area, but if you're going across a long piece of stock, you can retract a certain distance and be able to get rid of all that built up material as it runs across. You can set the length of cut, you can set the time interval, or you can set the length of chip that you want before it gets removed. And then your retract option as well. All right, so then we have rapids, leads, advanced feed rates, and MDI for the roughing. And for the finish pass, our finish tool, turn on collision detection, and then rapids, leads, advanced feed rates, and MDI. Awesome. Then we do our groove operation. I just right-click on machine setup 1, lathe groove, I'm just selecting these 2 lines here. I don't want to select this line because, again, I don't want to start from here and just air cut. I just want to start here and do my grooving operation in this area. By selecting OD for the operation type and from geometry, so that I'm not doing any air cutting. Doing a rough and finish, selecting my tool. We want something like this, OD groove. And the other option is setting up the tool for the finish pass. Make sure it's the same tool there. And we'll hit compute. So there's the groove operation. If you don't see any toolpath with a groove operation, usually what it is the width of the groove is smaller than the width of the tool. So you either need a smaller tool or a larger width there, but sometimes customers will call in and say they don't get any toolpath with the groove. Well, if the tool is too large, it's not going to create any toolpath if it can't fit in there. All right, so there's our groove operation, and that's it on this side. We can take a look at the simulation, and I'm going to turn on CAN cycles once we're done here to take a look at the G code and maybe cover a little bit about CAN cycles for the end of our live event today. All right, so here's the roughing on the OD and the groove operation from there. And that's it. So we'll close out of simulation. If we want to look at the G code next to simulation, we can click post. Here it is in separate moves. Separate moves are about 135 lines of code here. Got our rough, our finish, rough for the groove, and finish for the groove operations. 135 lines of code. Let's change it to can cycles. I'm going to right click on the turning operation, go to edit, and under posting, I'm going to change it to can cycles and hit compute. Now let's post that. The G code is now only about 85 lines of code. So we cut down about 50 lines of code in the G code, and that is all based mostly on the roughing for the turning, but I think also for the finish on the turning as well on the OD. And basically what this is doing, we'll take a look at the what the can cycle is doing here in the G code to shorten up the code and make things easier for you to be able to plot the points as well for the G code as well. So we'll scroll down here. Here's all of the comments, the program numbers right here, the comments for the machine, the tool. Here's the tool number, spindle speed. And then we get to G71 is our first can cycle for the roughing. And then this P value and this Q value. Now P10 is saying read P10. P10 is saying read the G code line number 10, your X and your Z coordinate. We can plot that point here. And then Q17 is saying read line number 17, which is your X and Z value here. So let's see where those values are. Let's do it from the backplot, I would say. It should be right. Let's see, we're at line number 10 is X 3.044, Z 0.097. So that would be where we're at currently in Z. Where we're at currently in X is going to be at the end. So we're going to move it all the way across. That is 11. 11's right here. So 11 is X 3.089 Z0. So that's where we're at right here. Actually, I'll just plot the point so that we can see it better. So what I normally do is I'll go to my current document settings, go to CAD, and change the points to something very large that I can see very well. Apply and OK. Then I'll go to Create 2D, go to Point, type in the number here, 3.089 Z0. Now, if I look at it here, X is 3.089 Z0. There we go. Now, if you look at it here, it's double the size because I'm in diameter mode. So I got to go divide by 2 so that we're right on the radius of the part. All right, so that's the first point that I plot for line number 1. And then line number 17 is Z minus 0.7822. And then X is going to be X positive 3.69 divide by 2 for the radius. So this is what it's saying for the two values here. P10, Q10 is telling the controller on the machine the start point and then the end point for your can cycle. So it's telling the software program read this point, then line number 11 is going to be this point, line number 12 is this point, 14, 15, 16, 17 is right here. All right. And what it's saying is what the controller is saying with this can cycle to the machine, it's saying basically saying, understand this profile right here. And this is what we've roughed out for the finish pass to clean up from that position. So it's also telling us in the can cycle, right here is the feed rate. Right here is the depth of cut of 50 thou as it has this profile from our original stock. Okay, and then we get down to the finish pass and our G70 can cycle right here. So G71 for the roughing, G70 for the finish can cycle. And it says read the points there. If I plot the other 5 points, it's going to be here. I think there's a couple of broken up lines here. So here, 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 and then up to here. So yeah, just to double check here, this is line number 10. Line number 11 is Z0 x 3.089 divided by 2. Next is Z0, basically minus 0.001 x 3.089 divided by 2. You can see that that line is broken up into little line segments for whatever reason. Z minus 1.094 x 3.1473 divided by 2. Minus 0.1094. There we go. So now we're at the corner, and then we should be going across from there. Z minus 0.1186 x positive 3.1489 divided by 2. This is why you can see the back plot is much easier than plotting all of these points. Because when I'm just going to get to the end here, minus 7818 x is 3.1496 divided by 2. So there we are. Those are the points that are plotted for the can cycle. It's telling the controller, start with your stock like this, and then just machine all of this area, and then do your finish pass just with those points there. So that's what that's doing. I like to be able, in the newer versions, just go to the cam tree, right-click on the roughing here, get your progress bar down to like this position here, and now you can just step through and you can see, okay, well, here is here is Z0 x 1.55. You just multiply that by 2 and you've got your first plot point right there. Line number 11. And then you keep going from there. Yeah, so that is a crash course on can cycles and also going through some of the features on advanced CNC lathe strategies. So please let me know if you guys have any comments any questions in the comments section. More than happy to answer them today. And I want to thank everybody for viewing the live event today on Lathe, being able to machine both sides of the part here, do a cutoff operation to be able to turn down the stock on both sides, do the groove operation, and finish everything up here. All right, let's make this look a little bit nicer here. That, and that. So there's our part file that we start with, doing the facing, turning of the OD, and then a cutoff, and then flipping it over and doing the other side of it. Cool. All right. I don't see any questions in the comments section, so I want to thank everybody for viewing the live event today, and we hope to see you in the next webinar. Is going to be April 1st. It's not a joke. It's going to be April Fool's Day. All right, cool. That's going to be April 1st, 1 p.m. Eastern Time. Hope to see you there.